Інформаційна служба Суспільного у студії з новинами Єгор Устинова.
Well, hi, good morning. Thanks so much for joining me in my shop. That was a little bit of, guess what? Ukrainian radio as heard over the internet. That was not a shortwave radio doing that. And of course, I don't speak Ukrainian at all. I have no idea what was said, but I am spending time on my shortwave radios trying to find anything that might be interesting having to do with the situation in Ukraine. You know, I'm Canadian, and there's a lot of Ukrainians or people of Ukrainian background here in Canada, a lot. And I grew up with kids whose parents had immigrated from Ukraine. So Ukraine is an important friend, I guess I could say, of Canada. So it's really too bad what's happening there. So now, laying all that aside and just getting back after this radio. So I ended the last video testing some of the key tubes, the FM tube and the two output tubes. I didn't put that guy back in. But there's 4 more tubes in here, and the radio is weak and not performing well. Maybe it's because of one of these 4 tubes. So I'm going to continue with the tube testing, and we're going to work our way through them, find out if there's a bad tube in this radio. Okay, first tube I've pulled out is the ECH81, except it's not an ECH81, it's a 6AJ8, which is a North American equivalent of that tube. So we're going to put it in my tester and give it a shot here, see what happens. Let's just change the lighting a little bit. Very good. So I believe I have this set, but we're going to double check it. 6AJ8, 6.3, 4, 15L, 00176, 00176, 0035, 0035. Very good. D is for the plate. And 46 here. Very good. All set. Very hard for me to see. Again, things look brighter on the camera than they actually are. In here, a very snowy day, another cold day with lots of snow falling right now. Winter is just not letting go here. Okay. What was that? The meter kind of jumped up there. Could be a charge on one of the elements. Yeah, we're going to assume that's what that is. Okay, for this tube to be good, it must be above 1180. So 1180 is about here. Here we go. Oh, man. Oh boy, that's pretty much close to totally dead. Now, is it because it's in here? This often happens. I have a bad contact. Oop. What to think? What to think about that? Oh boy. Wow. I don't know what to think. I see that meter get up there a couple of times. Well, I don't think I'm going to make a positive test with this tube tester on this tube. I think this particular socket is really bad in this tube tester. Oh, okay. Let's try something else here. Unfortunately, all of my tube testers are suffering from worn out sockets. This one may not be any better. So I have this set for this tube. I've double checked it. I'll plug it in, see what happens. So this tube tester is old enough that when this tube tester was made, this tube didn't exist. So you have to look at supplemental lists to get settings for these more modern tubes. Yeah, modern. Okay, it's lit. There we go. Now in this case, the short test just is done with this light. The light stays on, we're in trouble. Flash doesn't mean anything. Flash is actually a good sign. Okay, and in this tester, I have to look over here on my computer. I have the listing here, ECH81. So the reject point is 1260. 2000 is what you would hope for. So a 3000 scale, 1260 puts us about here. So here and up. Here we go. What's my pointer doing there? It's jamming. It's a little better. Must be some dirt in here. What has happened? That's good though. That's a reading. So the tube is functioning. It's 2000 is up here, and the reject point's down here. The tube is functional. It's not the one that's causing trouble in this radio. Okay, we're just going to move on to the next tube. See how that goes. Ooh, almost made a tube testing error there. This is a two-part tube, so it's really two tubes in one. So now I have this set for the second tube. Let me double check the settings. 98030. 98030. Just 1 second here. 98030. 14 and 80. 14 and 80. This only matters if I have this switch set to English, and then you're reading replace or good. But I have it actually set on a scale setting here. So the good and the bad for this part of this tube is 2000 and 3200. So a good tube is going to put the pointer all the way over, and a bad tube is not going to pass 2000. 2000 sitting right here. Okay. Oh, there's definitely something wrong with it. Okay, whatever it was, I knocked it out. Whatever dirt was in there. So it's reading up high. That's good. This is actually testing as a fairly good tube. Okay, next one is an EF89. While we're giving the tube a moment to warm up, how many of you have noticed that there's a cat toy back here? Yeah. Okay. Shorts. I think I just didn't move the lever all the way. The switch. Oh. This is showing a short. So seldom is this seen. Well, now what? Oh, look at that. Is that me tapping on this? It's the tube going downhill. Wow, that's a huge warning. Very seldom do I find shorted tubes, but they do happen. Okay, first thing, have I got the settings correct? Is this really the tube I think it is? EF89. EF89. So the settings once again, just to be sure, because you don't want to condemn a tube accidentally. EF89. EV27839. EV27839. Well, I'm frozen here. Let's try it in the other tube tester and see what it says. Okay, I'll just keep using tube testers until I get one that says it's good. Then I'll be happy. Yeah. Okay, I'll have to set up the other tube tester here. Well, I've been stymied in trying a different tube tester on this, so I'm going to try a different tube. Here's another 6DA6. which is an EF89. It says right on it, EF89. Let's see what this one reports. And we'll just do it back in this tester here. See what happens. Get the same result or not. I could have found a very serious problem in that radio. Shorts in the tube elements, not good. Not good things. Okay. I can't even see that it's heated. Let's look for shorts here. Nothing. So there's no flashing or anything. Phooey. This suggests a dead tube here. Apparently I have 3 of these, or 3 more of these tubes. Does not seem to be heating at all. So I'm watching the pilot light to see if it flickers. Well, I think that's a dud. Yeah. Oh, that's too bad for... Wait a minute, this is warming up. I can feel some heat in it. Put it back in there. So I have another tube tester. It's actually a step up from these two, and these are good tube testers. These two. This one's extremely popular. Well, was popular, but there's a lot of these floating around. This is the Stark 966. This particular one was owned by the Laredo uranium mines. I guess for testing the tube in their Geiger counters. Well, let's see what it says again. So I usually expect a little bit of flashing on this. I don't see anything. And if we push the test button, we get nothing. It's definitely, wow, yeah, it's definitely getting warm though. So that's 2 tubes tested with question marks after them. We don't know for sure. Okay, let me find another one. Should be just down in the tray you see there. 6DA6. Can you spot it? Yeah. There's one. 6DA6. It's from the same place. Ritchie Electronics, Fairborn, Ohio. Yeah. Let's see what we get out of this. I have to write a letter to Ritchie Electronics and say, hey, this tube you sold 60 years ago? Come on. See if it's really what it says it is. Often the box says one thing and the tube says something else. This looks brand new. This I swear this is brand new. EF89. There's some bent pins here. EF89. Just double checking you got the right tube. In you go. Yep, I can see this. I can see the glow. Okay, how do you respond to the short test? It responds like a normal tube. Okay. Push the button now at EF89. I've forgotten what the numbers are on it. Let me just look here quickly. What am I doing? I'm totally lost. EF89, single test, and the bad is 320 and the good is 2000. So 3000 scale. The bad, I forgot already. Holy smokes, 1320. 1320. It's got to come above my finger. Okay, we're in the good. I'm going to put this one into the radio so I don't get confused. Because at any time, my cat could come in here and distract me. I'm going to put the original back in and see if it still reports a short. What's happening? No, it's not working at all. Here it comes. Wow, tube testers, great things. Nothing. Okay, holding the button down. This is a bad thing to do. Just watching for any pop-up on there. Maybe this thing bit the dust right on the spot. Couldn't possibly have mixed them up with that other bad tube, did I? She's a nothing. Did I? How could I? I couldn't have possibly. Could I? Yeah, I could have. I'm capable of mixing things up. Don't see how though. Of course, that's how you mix things up, right? You don't see how. The tubes are dying right in front of us here. I saw a little tiny flash. Warm. Well, that's all very odd to me. So I think we know the tube that's in there is, well, it's testing good. So we know that. So we've made a change in the radio, a significant change. This is this tube here, which is the IF amplifier. Okay, that was kind of interesting. We'll go on to the next one. The next one is EABC80. So a lot of letters. It's a busy tube. EABC80. I'm going to have the same challenge getting it set up on here. So I'm going to stop while I deal with that. Okay, we're all set to do an EABC80. 4 tests to test this tube. I've double checked this already, so I'm going to boldly plug it in. So I'm guessing offhand there's two diodes, a triode, and there's something else in there too. I wonder what that is. Okay, shorts. There's no flashing. Oh my gosh, come on. Come on. Nothing. Well, we're not doing well here today. There's actually totally separate tubes inside there. They're like separate plates and that. EV. These two are the heater settings, filament settings. Call that. I don't think it's heating up at all. Well, there's no way that radio worked and this is totally dead. It just can't be the case. We're having a bad time on the tube testers today. Boy, oh boy, oh boy. Oh my gosh. What am I going to do now? Well, I'd say, when in doubt, get out another tube tester. Oh my gosh. Okay, so this is a lesser capable tube tester, but it'll do the job. We're interested in really, does the tube work or not? That's really the question we're asking. So this tube tester is different. Oh, it says dynamic. It says dynamic on it. See, this one is a mutual conductance tester. This one just says dynamic. Well, dynamic or not, let's use it. Okay, release the buttons. Release the buttons. Turn it on. I've used this one quite a bit for kind of quick tests and the like. So E, A, B, C. Not there. I have to start with the lid on this one. So look for E, A, B, C. 80. Same as a 6T8. Is it really the same as a 6T8? Huh. Okay. There's just too many tubes in this world. So we'll dial up 6T8. I'm pretty sure I have a lot of 6T8s. 6T8. Okay, here we go. 6.3. Top row buttons is A129, A129, and the bottom row is A67, A67. The plate setting is 35, and when we go to test, we test with the W and the X button. Down we go. This is the short test here. So let me grab the tube. Tube never warmed up in the other tester. My gosh. Okay, we'll try it in this one. I need the 9-pin socket. Here it is. Nine pins? Lots of pins. Okay, we'll give it a moment. I can see it's at least one filament's going anyway. Give it a moment. Now this one's kind of interesting for doing the test. You do the test here. It tells you what you're testing. Cathode plate, grid 2, which would be a screen grid, and grid 1, which is the control grid. And then there's a way of determining how much of a leak it is with this control. And read the actual amount of resistance in the leak, if there is one. Is there one? So I think the flickering light is to be ignored, I think. Too many tube testers in my life. So maybe this is how you do it. You back this down until you get the light to go out. I should really read 1 megohm. Paralyzed again. Well, you're having a hard time seeing that light. Flickering there, yeah, you can tell it's flickering. Okay, so let's carry on with the test. So what I'm doing now is, this is a good bad tester. It's just not good or bad. W, I'm making sure I push the right button. WX, and there's a series of tests here. WX, WX. She's in the good. Okay, next test. We can dump the bottom row and replace it with just a 4. And we repeat the test. This time it's, oh, we gotta change this to 17. Almost missed that. X and Z. X and Z. She's good. Next test is an 8. Pop the buttons, push the 8. 17, X and Z. X and Z. She's sort of good. And then the last one, we change the first switch, first button. I think I have to pull this out to do this. Pop them both out. 1, 2, 3, 5. 1, 2, 3, 5. Put the 2 back in. "17, X and Z." She's good. Okay, so this is a functioning tube, even though it showed up a little weak on one test. The tube is working. Okay, tangled up here are my cords. Okay, we have one more tube to do. One more. So we've replaced one so far, which is one that could explain bad performance, especially maybe in the FM range, because in the AM and shortwave settings, the tube that's weak is dealing with about a 500 kilohertz signal in the IF. But when you switch it to FM, it's now dealing with a 10.7 megahertz signal. I'm pretty sure it's 10.7. That's much, much higher. And maybe the tube just can't do it well at all in FM. So it works a little bit in AM, works much less in FM. That's my thoughts on that. Where is the tube identifier here? Well, there is no label on this tube. Oh no. Well, we can't be sure it's the correct tube, but wait a minute, it's way down here, I think. Little print. Let me look under a brighter light here for a moment. No, those are like manufacturing numbers. There's a lot of information on these tubes about what factory they were made in and all this kind of stuff. Well, we'll have to assume this is the correct tube at this point. And the correct tube would be, have to look on that tube chart here. We're on to EBC81. That's correct. EBC81. EBC81. Do you show up on the list here? Not here. Here. EBC, because they're not all on this list. EBC81. EBC. Son of a gun, it's not in here. EBC 9091. EBC. Did I mix up the numbers? I can do it. EBC 81. Wow, this is really getting a tough go here. Okay, I'm going to stop and see if I can figure out what tester I can test this tube on. Well, it's on the supplementary list for this guy, the European supplementary list. So I set the settings and I've double checked them. Let's see what happens now. I think I saw my pilot light flicker. Yeah, you'd think you're better off with more and more tube testers, but I don't know. I don't know. Okay, let's check shorts. Oh, another one. What was that? That looked like a charge depleting on the tube. Let's go through it again. One more time. I think we're okay. Okay, so this particular tube, let me get what the results should be. There's 3 tests for this tube. 690, 700, and 1100. So get above 700. Get above here, We're golden. Oh, it's right on 700. So I do a little sensitivity check here, just how critical are these settings. Well, that's English, that doesn't matter. Just this one. Well, it's supposed to be 15. You know, I don't know how accurate any of this stuff is anymore, so maybe my tube tester is a little hard on tubes. Not as fair as it could be. Well, it's functioning, but it's right on the limit according to my tube tester's ranking here. Now we'll switch to the next test. It's a 2 diode test. So EV06030. 06030. This tube tester, you can change these settings while the tube is sitting in here, as long as these are set and not changed. These are the heater ones. That's to speed up testing. You set these two and pop the tube in, and while the tube's warming up, you set these ones. The only time voltages are applied is when the button is pushed. But not all tube testers are like that. Some tube testers, you start changing the knobs while the tube's in place, so you'd be setting up shorts and stuff inside your tube tester. You don't want to do that. Okay, and I need the number. The number is, so this is a diode test. So diode's okay is marked up here. So anything above where my finger is, we're cooking. A diode test, diode. Oh, it's a weak one. Not very reassuring at all. So that's a weak test there. The next one is just change the 6 to an 8. Change the 6 to an 8. So we're doing a different diode plate. Oh, it's weak too. They're all testing weak, like all the sections in this tube, and that suggests the cathode is worn out in it. Wow, that's another weak tube. Yikes. Yikes. Yikes, because I don't know if I had one of those. I don't know offhand. Okay, we'll see if I can find a replacement for that tube. Well, this hasn't gone well. There's one of my tube substitution books. And if we look up EBC 81, 6BD7. Notice an EBC 80 is a suitable substitute for an 81. 6BD7. I don't have any in my curated tube lists. I have loose tubes I have not gone through yet. What are the chances I've got one of these in there? 6BD7 is a setting that this doesn't have. Probably on a supplementary list, probably appears. 6, did I say that? That's not right. 6BD, yeah, does not appear. 6BD6, over here, no 6BD7. Well, the situation is the tube is functional, it's just very, very weak, and I think we have to carry on just keeping that in mind. So what has happened here? It hasn't gone nearly as well as I would hope. We found one very bad tube and replaced it. Got another weak tube I'm just putting in now. And the good news is the 2 output tubes seem pretty good. And the FM tube tested good too. Well, we should give this guy a test. Run. See what comes out of the speaker with that one tube replaced. Maybe, I mean, that's a very important tube. The one I replaced. Okay, so is everything set? I think everything is just as it was. Here we go. Broadcast. Okay, dim lights behaving correctly. This is not sticking. not a lot of volume in this. I gotta go all the way up to here. And I believe this tube, the one that we're just looking at, is the preamp tube for the output tubes. And that might explain why it's such a busy tube. It's got all kinds of parts. It's meant to work in stereo situations. Okay, let's try FM. FM is the key. I find it kind of sad too. Well, I think it's marginally better. Where's the pointer? Pointer's way over here now. It's so hard to see the pointer. What's down here? There it is, right there. Well, it's turned up almost full. So this guy is a record player and a radio, and perhaps the owner is really more interested in playing records. And if that were so, then all you would really need is the amplifier working in here. That'd be the two output tubes and the preamp tube, which I'm pointing at is that same tube again. Uh-oh. So the weakness could be not related to the tubes at this point. The other factors, especially a raft of old capacitors in there. Oh, I'd really like to know. How can I know? I don't know. Oh no. Wow, I'm in a bit of a crunch here with this radio. I mean, if I go ahead and do all those capacitors, and when it's done, it sounds exactly like it does now, which is possible. Then what? I don't know about then, but now might be a good time to look at some swans. Okay, spent a few minutes pondering the situation here and trying to come up with alternatives. One is, what if my FM antenna here is just crap, and so the receiver's not getting a good signal to chew on in the first place, and that's why it sounds so weak. Not very likely, because I gotta turn this up so high. But one way to get around that is to substitute, instead of an antenna, a piece of equipment, and I have to have a nice piece here that'll put a pretty strong signal into the back of this radio if we want to do that. Another one is, although I've tuned the radio around on the broadcast band, I haven't picked up much, and it's probably because just the way the antenna is and the like. I've never tried the shortwave bands. I should maybe supply a good shortwave antenna signal and then hunt around on the shortwave bands and see how they're working, just in case I'm reaching the wrong conclusions. You know, the radio doesn't work because the tube is weak and there's no volume. And so another approach is, well, could you play records with this? How do I know that for sure? I'm thinking the problematic tube here is going to interfere with that. It's the reason why the set is so quiet. I don't really know that. So I could supply a signal into the amplifier and see what comes out the speakers. That's a little more tricky than normal because this has European style plugs or DIN style plugs on the back, which just are a little more difficult to set up. But doing the FM thing is not too hard. Why not try that? Let's try that. So I'm going to pull the other antenna out here. This should be an okay antenna. There's no problem receiving a number of FM stations here in my shop. Turn off the tube testers. Switch on this guy. His output comes on this cable here, which I'm going to attached to the back of the radio. The radio's not on right now. Happens to have come with these very fortunate plugs. Like that. As I mentioned, this puts out a strong signal. That doesn't put out, music or anything like that. It puts out test signals. So we have to kind of go with that. Okay. Also, it only broadcasts. This is on now. Right, it's on now. Only broadcasts at 100. Right around in here. Now, let me just check the settings on this guy. He's set for 1000 hertz tone in mono mode. Should hear 1000 hertz coming out of both these speakers. Put this on 100. Okay, well, there it is. Now this is hard to make judgments with. So we should hear, tuning through, we should hear small sound, strong sound, small sound. And it should be fairly symmetrical. Come back this way. Small sound, big sound, and then the last small sound it's not very symmetrical, so no surprise, needs a little bit of alignment. So there's some decent volume coming out of it now. Let me turn the RF rate down. It is right down. It's a fairly strong signal coming out of there. Try a different frequency. 400 hertz. See, giving a strong signal. Doesn't sound so bad. Another possibility is just the alignment is off enough that that's what's keeping it quiet, making it less sensitive than it should be. Give it a good signal. Okay, we're going to try the shortwave approach now. Let's see what happens here. So this is connected to an outdoor antenna. Just switched on in the shop here. Okay, turn the radio. Let's go this way. I'm going to get rid of the FM part of this. Okay, I'm going to move this down into where the shortwave antenna would be connected. And I'm just going to take a look at the back. Make sure I'm not making a mistake here. You can see antenna on the left, ground on the right. Antenna on the left. Those sneaky people. So we're going to start with just hooking up the red wire here. Antenna on the left. The volume is down. I think we're still on FM. We'll start like that. We'll connect the ground later. Something getting hot in this radio besides a tube. There's a lot of heat from these two tubes. Shock here. I'm trying to feel the output transformer, but I don't think that's really one to worry about. Where's the power transformer in this radio? Down underneath. Okay, so we can check the power consumption here. 55 watts. So I think it said 60. I think 55 watts. That's quite reasonable for a radio this size. Okay, we're going to go to shortwave number 2. Lots of volume there. Shortwave number 2 is here, 1817.876. It's a fairly strong signal at 9.3. I think I have it tuned in on another radio right now.
A very lethal question.
Okay, so what you just heard is 9.330, which would be right about here.
So I'd like to close with a personal faith promise from Psalm 27 verses 5 and 6. And it says this, "For in the time of trouble he shall hide me in his pavilion."
Tabernacle shall he hide me. He shall set me up upon a rock.
You shall set me up upon a rock. So there we are. It's roughly in the right location. 9.3 is just a little further to the left here.
I will sing, yea,
Not excessive volume here.
the voice is coming through, folks. We always enjoy hearing from you. Just go to
Big fat hum in the during the volume. Well, that's quite acceptable, really. See what else I can find here. Maybe we'll find Ukraine. I don't think Ukraine's on shortwave. Teletype. Teletype's so close to a broadcast band, I can't tell for sure if we're still in the broadcast band. Sometimes teletype's used as interference to block signals. Last night I was listening to Voice of America, unfortunately weak and not in English, so it wasn't worth listening to, but there was teletype on top of it. Teletype on top of Voice of America within the shortwave broadcast band. So I'm not saying that's what that was. Okay, let's go up around 11.5. Nope. Okay, let's go up around 13, just above 13. Oh, what's happening there? Something ugly operating in my shop here. That's exactly what that was. That's too much power fed to the LED lights that you see shining on my hands. And you supply too much voltage to those lights. There's some kind of voltage regulator in there, and when it comes into action, come on, camera, you can do it. I know you can do it. There we go. Jeez, it's tricky to tune this radio on shortwave. A bit of backlash in it. Backlash means you turn the knob, and when you let go, it relaxes back a little bit from where it came. Very annoying. And that can be due to a little lack of lubrication through the system here. Okay, we'll go up around 15. What's up there now? Nothing. Nothing at all. Okay, so we're going to compare. Wow, some volume is up a long ways now. That's full. Go back down here. Where did I pick that station up? Oh, there it is.
You are loved with an innocent love that eternity itself will never fully reveal.
So that hum that's coming along,
Has inscribed
it's
you.
possible it's coming from the transmitter. They're transmitting that hum,
He holds you.
or it's an indication of a difficulty in the radio. Oh, what just happened now? Everybody left. The volume just dropped right out. Where'd everybody go? Oh my god, I mean the Russians just bombed the transmitter. Okay, so tube weak in the socket. Don't get burned now. Hot tubes. These tubes are held very strongly in the socket here. They're pretty good sockets. Well, I don't know. It's going downhill here quickly. We're going downhill. Anything funny happened with the wattage? 53 watts. 110 volts on it. Well, what do you do? The thing is failing right in front of me. Oh, wait a minute.
You have been listening to WLC Radio. Join us again tomorrow on WBCQ at 9330 kilohertz on
Yeah.
the 31 meter band.
9330.
Last Chance Radio. Preparing the people for the Saviour's soon return.
Yeah, Last Chance Radio preparing us for the return of well, I don't know what's happened. Something happened while we were using it. Who knows what it is? This is a very strong signal, which is why it's coming through. But I've got this almost full to get it to come out. It's like just the audio level dropped off, so you know, maybe it's this tube actually a bit more dust. That's a dust-filled tube. Wow, this is a really sad situation. I think I'm going to end it here probably for today. This has gone way longer than I expected on the tube situation. I feel like I've fallen into a bit of a ditch here with going forward with the radio. So I'm going to have to spend a little bit of time sorting out how to proceed here. Basically, it's not worth going in changing all these capacitors if in the end this tube is bad and I don't have a replacement for the tube. I guess I have to purchase one. That's going to take some time to get one. So if I don't want to proceed until I know the world's last chance. Yeah, too bad. Okay, well, thanks a lot for watching, and I don't know what I'm going to do next. I don't know what I'm going to do. I don't know. See ya.